Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on S parameter. On my first part of this video discussion, firstly, I will do a quick introduction. Okay, what is S parameter? Okay, so the word S actually stands for scattering. Okay, so this video, I'm going to explain why we need to have another set of parameters. Beside S parameter, we already have this Z, okay, which is also known as impedance parameter. We also have the Y, which is known as the admittance parameters. This video, I'm going to explain why we need to have S parameter. In short, S parameter actually has the application for high frequency. Next, okay, I'm going to explain when we actually do a measurement. I'm not sure whether you wonder why we need to terminate a port before we can execute the measurement. Okay, so this video will also explain the rationale why we need to terminate a port before we can conduct any form of measurement in S parameter. So basically, this will be the objective of this video. Guys, if you're keen to know more about S parameter, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on S parameter. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, okay, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Firstly, let's quickly define what is S parameter. Okay, so S parameters, which is also known as scattering parameters, they are in fact used to describe the input and also the output relationship between input and output ports in an electrical system. At high frequency, it becomes essential to characterize a given network in terms of waves rather than voltage or current. So therefore, S parameters actually utilize wave to do this form of circuit analysis. You can see that right in the middle is actually a two-port network. You can see that S parameter, in fact, will be using to describe the performance of this two-port network. On your left will be the input port. On your right will be the output port. As he mentioned earlier on, okay, so basically for S parameter, we actually have wave. As you can see here, we have the incident wave. We are going to have the so-called return wave also. We basically use wave to describe the circuit, okay, using S parameter rather than voltage or current. Okay, so basically this is the discussion. So why we need to use wave rather than voltage or current? Okay, so because in RF design, traditional parameters like Z, Y, or H parameters, they become not practical anymore. Okay, because short circuit don't appear like short circuit anymore. Open circuit don't look like open circuit anymore. And with this, it become impractical, okay, to analyze the circuit at this high frequency. Okay, so what does this mean? Okay, let's take inductor, okay, to represent short circuit and capacitor to represent open circuit. Let's do the short circuit first. For example, an inductor, okay, basically the reactance of the inductor, which is equals to 2 pi FL, if you still remember. Okay, so basically the XL, okay, for inductor, which is equals to 2 pi FL. So at very low frequency, which means that I'm going to have a very small number in terms of the frequency F. Okay, so basically the total reactance will be very small because of low frequency. However, imagine this, when the frequency keep on increase and increase, it become high frequency. And the frequency become a very huge number, which makes the reactance of the inductor not a small number anymore. At low frequency, it can be a short circuit. However, at high frequency, okay, the inductor may not be a short circuit anymore. It become a quite a significant reactance number. So therefore, at high frequency, I can't use inductor to represent short circuit anymore. Same for this open circuit analyze. Okay, let's take the capacitor. If you still remember, the reactance of the capacitor, which is equals to 1 over 2 pi Fc. Okay, so from here you can see that at a very small frequency, okay, when you actually do 1 divided by 2 pi F, the small number, you actually has a very big reactance. So I can still have a open circuit. However, when the frequency keep on increase and increase, okay, so the 1 divided by the number become a very significant number, and hence I cannot so-called use capacitor as an open circuit anymore. Okay, because of all this rationale, okay, therefore we actually prefer to use S parameters for a higher frequency in order to analyze the circuit. Okay, so from here, you can see that this is actually a metric. Okay, so this is a metric to describe S parameter. And if I open up the matrix into these two equations, how I actually obtain these two equations? Okay, so B1 is equals to S11 multiplied by A1, as you can see here, plus S12 multiplied by A2. Okay, so this is the first equation. Next equation is actually P2, okay, which is equal to S21 multiplied by A1 plus S22 multiplied by A2. Okay, so basically this is two set of equation, okay, to describe the two-port network in S parameter. Okay, but let me go through what is actually B and also A. Okay, so from this diagram here, you can see that A1 and A2, they are so-called the incident wave. What is incident wave? Incident wave means that they actually go into the device, as you can see from here. Both A1 and A2, okay, the wave actually go into the two-port network. Okay, one actually stands for input, two actually stands for output. So from here you can see that A actually is so-called the incident wave because they go into the two-port network. For B1 and B2, they are called the reflector wave because they actually leaving the two-port network. Okay, again, the one will be still the input, the two will be still the output. Okay, so basically this is the fundamental discussion on S parameter. I will come to this equation shortly, but over here, you can see that the key motivation why we need to have S parameter is because of frequency. When we actually analyze the signal, okay, or the circuit, okay, at a higher frequency, we need to use S parameter because voltage and current cannot represent anymore. Because short circuit don't behave like a short circuit, same for open circuit. Okay, so therefore, we need to have another set of parameter, which is S parameter. Okay, so next video discussion, okay, I'm going to explain why we need to terminate a port before we can actually obtain the measurement result. Okay, so basically this is the second objective that I want to achieve for this video. If either port is terminate with the characteristics impedance, okay, so the reflected term for a signal sent to that port becomes zero. Okay, thus if port 2 is terminate in Z0, okay, and an incident signal actually apply to port 1. Okay, so let's not dwell so much on this so-called these sentences here. Okay, but let me explain. Okay, so let me come into this equation first. Okay, so these are the two equations that I illustrate on the previous so-called slides. Okay, so in order to get what is actually S11, for example, for this case here. Okay, so if I can make A2 equals to 0, this whole thing will become 0, right? If A2 equals to 0, anything multiplied by 0 will become a 0. Then in order to get S11, okay, will be equals to B1 over A1, as you can see from this equation here. Okay, so if I want to get my S parameter, okay, so if I'm able to meet my A2 equal to 0, this whole thing will be disappeared. And therefore, to get S11 will be equal to B1 over A1. So as shown from this equation here. So next, okay, if I want to get my S21, how can I actually get my S21? It's the same rationale. If I can make this A2 equals to 0, this whole thing disappeared. So therefore, S21 will be equals to B2 over A1. Okay, so this is the meaning here. Okay, so next I'm going to describe how to make A2 disappear. Okay, so basically this is what it means. Okay, so if I have an incident wave, okay, which is A1, and if I want to find S11, okay, I need to know what is the wave at B1. And if I get this ratio, then I will be able to obtain what is the value of S11. Okay, provided that I ensure that A2 is equal to 0. Next for S21 here, okay, so if I want to know my S21, okay, again, this is the incident wave that I actually supply to the two-port network. Okay, so if I know the wave at the B2, then with the ratio of this B2 over A1, then I will be able to obtain this S21. Okay, so basically this is the objective, how to get the S parameter, but I'm going to explain how to make this A2 is equal to 0, which means that no refracted wave, as you can see from here. Okay, I will come to this shortly again. Okay, but before I come into this, let me describe, okay, why we need to terminate a port with 50 ohm before we can commence any measurement. Okay, let's say, okay, from you can see that from this diagram here. Okay, so basically we have a transmitter, we have a transmission line, we also have an antenna. Okay, so all these can be made by different companies. Okay, so different companies actually make all these so-called device here. So how to integrate them into one? Okay, so now imagine that this is the whole change, and when I actually want to add an amplifier, okay, in between the transmission line and the antenna, okay, how should I be able to add? Okay, so for example, if I'm a company that's selling this antenna. Okay, so I know that my antenna will be integrated to the whole chain, the whole RF chain. So as to ensure, okay, they are able to integrate as one. Okay, so what I need to do is when I actually look into this point here, the impedance of the antenna need to be 50 ohm. Okay, so now, as I mentioned earlier on, I would like to add an amplifier inside. Okay, so as a manufacturer for amplifier, let's say another company make this amplifier. Okay, so what they need to ensure is when they actually look into this here, they need to be ensured that they are actually 50 ohm. Why? You probably will ask. If you still remember, okay, when the impedance they are matched, maximum power transfer actually occur, which means that all the power from the source will be passed on to the load. However, if there is some form of mismatch, as you can see from here, some will have return loss, which means reflected wave. Not all the signal will be transmitted from the source to the load. Some will be lost. So in order to ensure maximum power transfer, so therefore for different manufacturer, for different so-called component or device, they always ensure that when you actually look at both the input and output, they are all 50 ohm. For example, on my filter design, okay, before you actually can do a filter design, you actually have an input and output matching circuit so as to ensure that when you actually look into the filter, for example, they are all 50 ohm. Okay, so basically this is a rationale, okay, why we need to terminate a 50 ohm, okay, to one of the so-called unused port before we actually commence the S parameter measurement. Okay, again, I'll come to this, but this is the rationale. Okay, so another reason why, okay, basically is also the measurement. Okay, so this is a vector network analyzer. Okay, so if you can zoom into this part here, you can see that the port is actually 50 ohm. Okay, so which means that when you actually look into the port inside this vector network analyzer, when I actually look into the impedance over here, they are actually also 50 ohm. Okay, so this is to ensure maximum power transfer, okay, from the vector network analyzer all the way reach over here. And because of this, as I mentioned, when I actually design the filter, okay, I will put my input and output mesh so as to ensure that when I actually look in over here is also 50 ohm. So when this is done, maximum power transfer, okay, during the passband will pass the filter, and therefore this is a reason why we need to terminate 50 ohm, okay, on any port that is unused. Let me come to this on my next slides here. So this is my next slides, which I have illustrated earlier on. Okay, so why? Okay, so basically this is the equation here. So as to ensure that A2 equals to 0, okay, so therefore I need to add this so-called characteristics impedance of 50 ohm over here. So remember, this is basically the known so-called source or incident wave. Okay, so at the outcome, I will have my so-called the output wave and also the reflected wave at the input here. So as to ensure nothing A2 equal to 0, I need to have a match circuit. If both are 50-50, then I will not have any A2 anymore because it's a perfect match, 50 ohm to 50 ohm. When I actually look inside here, it will be 50 ohm, and my characteristics impedance also 50 ohm. So therefore, I won't have any A2 over here. So basically, I actually achieve this A2 equals to 0, as you can see from here. So with this, I actually will be able to get my S11 and also S21. Okay, so basically, I have an incident wave. Okay, I will measure B2 wave and also B1 wave, And based on that, I will be able to obtain my S11 and also my S21. Okay, so basically this is the reason why we need to terminate any unused port with a 50 ohm load over here, as you can see from here. Okay, so this is the reason why. Okay, so before I continue, guys, okay, I urge you to help this channel by like this video. Okay, when more you guys actually help to like this video will have a better chances to reach out to a larger audience. So guys, help me to press the like button now. If you have learned something from this video, please consider to subscribe, okay, to so-called to subscribe so that you can receive, okay, this form of content once I upload it. Okay, so please also remember, okay, to turn on your notification bell. Okay, so with all this explanation, okay, it will be the same, okay, for when we actually have an incident wave at the output port over here. So the key reason now is how to make A1 equals to 0. Then I need to have a characteristics impedance of 50 ohm terminate over here. Okay, then I will have A1 equals to 0. And with this, if I'm able to measure, okay, this A2 is actually my incident wave, which I know, okay, from the, let's say from the vector network analyzer, I will measure my B2 and B1 signal. Then again, from here, you can see that I actually successfully obtained my S22 and also S12 parameters. And from here, I have successfully, okay, so-called derived the S parameter that I want to have, okay, based on the measurement using vector network analyzer on the DUT. Okay, so let me continue, okay, to describe a little bit more on S parameter. Okay, so by definition, okay, an S parameters is the ratio of the voltage, both the magnitude and also the phase, okay, of a signal that is actually coming out, which is at the output of the port, okay, to that of the signal that is going into the port, which is the input port. So as I mentioned earlier on, S parameter actually used to describe the relationship between input and output port. Okay, so the source and load impedance, they need to be 50 ohm, which I have just illustrated earlier on. The S parameters of a device can be plotted on a Smith chart or polar plots to show changes with respect to frequency. Keep this in mind, when your biasing condition change, your S parameter change. When your frequency change, your S parameter also change. Okay, so earlier on, I have so-called defined why they are named in this rationale. So again, if you're keen to know why, okay, please take a look on the playlist under the description. Okay, over there you will be able to understand, okay, why S11 is known as input reflection coefficient. Okay, so you need to take a look on the playlist to have a complete understand on S parameter. Okay, so the scattering matrix, in fact, is a very simple mathematical construction that actually quantify how RF energy actually propagate through a multi-port network. Okay, so earlier on, I actually just described the S parameter based on two-port network. However, S parameter can be also utilized, okay, on a multi-port network. Okay, the S parameters is what allow us to accurately describe the properties of complicated network as simple black box. Okay, for an RF signal incident on one port, some fraction of that signal actually get reflected back. Okay, so basically this will be S11 out of the incident port. Okay, some of it actually enter into the incident port. They enter into the incident port and appear at the output port. So this can be S12 or S21. And then they actually exit to some or all of the other ports, perhaps even amplify or attenuate. Okay, so this is what I have shown to you earlier on a two-port network over here. So this is the equation. Again, I have described all these, okay, S parameters equation. Okay, so I just want to keep the thing easy. Okay, so because it will be very confusing to know what is A or even B. Okay, so 1 and 2 I think is quite easy. 1 is actually input, 2 is actually at the output. Okay, so for example, when we actually want to describe incident, okay, so basically for this case here, the incident voltage wave, you can see that I put a plus to describe incident voltage. So 1 will be at the input, 2 will be at the output. So I know from the plus term here, this is actually an incident voltage. While for the refracted wave, I can use this minus to denote. Okay, so this will be the refracted wave at the input port. This will be the refracted wave at the output port. Okay, so with this, we can actually express. Okay, so this is what we earlier on described, what is actually S11. Okay, so B is actually the reflected wave, so therefore it's a minus. The rationale one will be the same, so this is actually the reflected wave at the input. Okay, so A1 is actually the incident wave, so therefore it's a plus, so the plot is the same. So it will be the same for all the S parameters. Okay, so with this, I like to end my discussion. Okay, please help to like this video and subscribe to this channel. Okay, so in this video, firstly, I define what is S parameter. So next, okay, I actually explain why we need to terminate unused port before we can commence the measurement of S parameter. With this, I like to end my discussion. Okay, please help to like this video and subscribe. Once again, thank you so much. I hope to see you guys soon. Bye for now. Thank you so much.